QED and QCD are both quantum field theories that describe the interactions between particles, but they are based on different forces in particles. QED describes the interactions between electrically charged particles such as electrons and photons, while QCD describes the strong nuclear force that holds quarks and gluons together to form protons, neutrons, and other particles. One of the key differences between QED and QCD is the nature of the particles involved. QED deals with electrically charged particles, which are easier to observe and manipulate in experiments. On the other hand, quarks and gluons, which are the particles involved in QCD, are never observed as free particles due to confinement. This makes it more difficult to test the predictions of QCD in experiments. Another difference between QED and QCD is the way that they interact. In QED, the interaction between charged particles is mediated by the exchange of virtual photons. In contrast, in QCD, the interaction between quarks and gluons is mediated by the exchange of virtual gluons. This difference in the particles that mediate the interaction leads to significant differences in the behavior of the two theories. The complexity of the interactions between particles in QCD is also a major difference between the two theories. In QED, the interactions are relatively simple and can be represented by a few Feynman diagrams. However, in QCD, the interactions are much more complex and can lead to the creation and annihilation of particles. This complexity makes the calculations in QCD much more difficult than those in QED. In summary, QED and QCD are two distinct quantum field theories that describe the interactions between particles. While they share some similarities, such as the use of Feynman diagrams to represent interactions, they differ in the particles involved, the way the interactions are mediated, and the complexity of the interactions themselves. From https